Hello everyone, this is Ricky Noriega and I'm gonna show you how to deploy the industrial edge computing MVP that we've been working on for some time now. This is an official demo just to show you what a new user would do to deploy this whole solution and perform the basic demos on top of it. This new user could be a partner, a customer, or mainly, I think for this first phase, it would be solution architects all around the world to show what the Red Hat portfolio is capable of offering to our customers in terms of edge computing and especially these industrial or manufacturing use cases. So well, since I'm going to take this role of the new user, I've created a couple of profiles. First of all, in GitHub, so I'm Monkey the user, and I've created this organization or profile. The same for Quay. And I'm going to explain a little bit what are the pre-requirements or prerequisites that you would need to perform or deploy in your own machine, and from there we will deploy a couple of OpenShift clusters with some components on top, and all of this will be semi-automated via the blueprints concept that we have been talking in the past. So let's get going. First of all, let's say that I'm gonna run this whole demo from a Fedora workstation, Fedora laptop. The first step would be to create a directory in your home folder, which is the .kni directory we can see here. I've already created it and placed a couple of files in there. These are prerequisites for this demo, so it is mandatory that we put these files with these names in that specific directory. So first of all, we have the public key from our system. This is going to be injected in the cluster, so we can SSH into the nodes if we want. This is the pull secret from OpenShift from cloud.redhat.com. So it's our OpenShift pull secret that we can download from the website here. If you go to cloud.redhat.com /OpenShift install and you pick your platform, you will have these steps and you can copy your pull secret and place it in that file with no spaces or anything, just paste it there. The name of the file has to be pullsecret.json, and this is a token from GitHub to be able to perform some automatic commits and patches to GitHub from our Tecton pipelines. We will explain this in the future, but this is basically our user and token from GitHub. For ease of deployment, we have built the following blueprints to run on Google Cloud Platform. In a more real environment, this would be running on OpenShift on bare metal or on some virtualization platform like Ref or even VMware. So the point is just to show what the Red Hat portfolio is capable of doing in terms of the use cases for industrial or manufacturing companies. And we are gonna deploy 2 clusters on Google Cloud Platform. So we would need to place our credentials in the following directory. So this is the service account from GCP, and it has to be located in this directory under your home folder with this specific name. So once we have these files in these directories, we are going to go to the Red Hat Edge Computing organization in GitHub, and we are going to perform a couple of tasks here. So there are 4 repositories that are of interest for me, for the Monkey user. First of all is the Blueprint Management Hub and the Blueprint Industrial Edge. A blueprint, as we mentioned in a couple of videos in the past, a blueprint is basically a declarative way or a recipe to declare a complete edge computing stack, from the infrastructure to the applications that are running on top, going through the cluster. So we can define how many machines we have, what version of OpenShift or Kubernetes we are running, and what kind of applications, if we are going to run a Node.js or any other kind of application. We are going to deploy 2 clusters based on these blueprints. So one cluster will be our management hub cluster, and a second cluster will be our remote edge computing site based on this Blueprint Industrial Edge cluster. So these two repositories are important for us, and then we will also take into account these Manuela GitOps and Manuela Dev repos, because with those we will perform some of the basic demos that we want to showcase to our customers or partners. So let's go to fork these 4 repos. Okay, so if we go to our GitHub profile, this is the expected result that we should see. So we would have 4 different repos: Blueprint Management Hub, Blueprint Industrial Edge, Manuela Dev, and Manuela GitOps. Once that we have these 4 repos forked in our GitHub profile, we have to create 4 different container repositories in Quay with specific names as well. This is because once we have the whole solution deployed, we will run some Tecton pipelines that will build images that will be deployed on all of our clusters. So, in this demo is only in our edge computing and management hub clusters, but we can extend this to a whole edge computing network. So here we are in our profile, which is Monkey the user, and we will create new repos for these images. So the name has to be the following ones: IoT-frontend, we make it public, and we start as empty repository. The next one is new repo, IoT consumer, public again, empty. Another repo called IoT-software-sensor, public and empty. And finally, let's do the IoT-anomaly-detection image. Okay, if we go to our repositories list, we have these 4 images. And one more thing is, once we run these Tecton pipelines in the Management Hub OpenShift cluster, we would need to push, from these pipelines, we would need to push the images to Quay. So we need a robot account that allows you to do this automatically. We can create a robot account here. Sorry. Here. New robot account in the namespace monkey the user. We can put whatever name here. Let's say monkey. Create a robot account. We grant access to all 4 repos, and we have to give right permissions. Okay, and one more step is that if we go to the robot account name here, we need to get a secret that will be embedded in our Kubernetes manifests. So pushing the images would be basically automatic. We would go here. We go to Kubernetes secret, view monkey the user monkey secret, and we have to copy this line here, which is under the .docker config JSON. We have to copy this to our system, to our Fedora system, and to the following file. KNI directory as always, and docker config.json. So we will copy this here. I'm gonna erase this afterwards, so there's no point on copy pasting this this token, because it won't be valid for long. Now we have, we have these 4 files in our KNI directory, which is good. All right, so we have all the needed files in our .kni directory, and we have already forked the GitHub repositories that we need, but we haven't changed anything from them. So we would need to change some URLs and some variables to adapt it to our own environment and our own repos. So I'm going to create here, let's say a workspace or a directory where I'm going to clone all my repos. I'm going to put these commands in the official documentation, but let's go one by one. So these are the repos that we are going to clone, right? And first of all, I want to put what is my GitHub organization. So in this case is monkey user. I'm gonna make this right now as well. So I'm gonna put another variable for Quay. What is my Quay org, which is monkey user as well. And let's do the cloning. All right, we have the 4 repos cloned in here. The next step would be to replace the name of the cluster and the domain of the clusters that we are going to deploy. Right now, those blueprints have a specific name and domain, but we have to adapt this for our own purpose, right? So we are going to, we are going to export the management hub name. So I'm going to call it Edge Monkey hub.gcp.dev cluster OpenShift.com. So have in mind that this domain is already configured on GCP. So if you want to deploy any OpenShift cluster on GCP, you can go to the official documentation and check what are the prerequisites that you need to configure there, like a DNS zone and etc. So I've already configured GCP to deploy with this domain, and this is just a name that I'm going to put to my cluster, the Edge Monkey Hub, right? So we have to do the same for the factory edge computing site. And I'm going to call it staging monkey.gcp.devcluster.openshift.com. Okay, and now I've created a couple of commands in order to replace all the needed variables. First of all, we need to replace the GitHub URLs from the Red Hat Edge Computing organization, where we created the blueprint, to our monkey the user GitHub org. This is going through all the files and performing a replacement of the string. And we are doing the same for Quay. I'm going to show you now the commands. We are changing the Quay repos from the Red Hat Edge Computing Quay organization to our recently created org, right? So instead of going to quay.io Red Hat Edge Computing, we want to replace it for quay.io my Quay org, which is monkey user. And finally, we are going to replace the name and domain in the blueprints for the management hub. Once that we have performed all the changes in our 4 repos with the commands provided in the official documentation, we need to push these changes to GitHub. So we have the 4 repos. Let's go one by one and check what has changed. In Manuela Dev, it doesn't change anything. Go to Manuela GitOps. We add all these changes, commit, let's say adapt to our own environment, and we push it to GitHub. And now we do the same with the rest of the repos. So let's go to GitHub and see if we have all the changes. Very good. We have the 4 repos, and let's see if the commits are there. Adapt to our environment, very good. Adapt to our environment. Finally, Manuela GitOps. Adapt to our environment. Very good. One more thing that we need to change, and we can do it on the web UI because it's very easy, is to change the name and domain that we have put in these variables. If you remember when we have done Sport Factory and Sport Management Hub, we have put a name and domain for our clusters, right? This needs to be reflected on the blueprints. So if we go to Blueprint Management Hub, Sites, Edge Management Hub, we go to install-config.yaml, 00 install-config file, and we need to change the name here. Let's edit it. If you remember, we put Edge Monkey Hub. So let's change this. Monkey. We commit the change. And if you have a different domain in configuring your in GCP, in Google Cloud Platform, you would need to change in this file. In the install-config.yaml patch, you would need to change the base domain. Right now, I'm sharing the same domain, gcp.devcluster.openshift.com, but if you have a different one, you would have to change it here. And it needs to be the same again as the variable that you put here. Is the same name and the same domain, all right? So we need to do the same for the Blueprint Industrial Edge. We go to Sites. This MVP is prepared to have multi-factories, multi-sites. But for this demo, we're gonna do only one site, which is a staging edge.gcp devcluster.openshift.com. And we would need to change the name again here. So instead of staging edge, if we remember the factory, we put factory staging monkey, right? So we need to change monkey here and commit changes. Very good. One more thing is we need to update a secret that is used for Kafka to communicate between both clusters. So we need to create in our own machine using this specific domain. We need to create a new certificate, TLS certificate, and a new key, and those will be embedded in the manifest. So we go to our system. Let's create the TLS certificate needed for Kafka and the data lake to exchange data. So first of all, we need to export this variable with the apps prefix and our name and domain for the Management Hub cluster. If you remember, we have put Edge Monkey Hub, gcp.devcluster.openshift.com, and now we will use OpenSSL package to create this key and certificate. Now we have to embed this certificate and key in the following files. So it's in Manuela GitOps config instances, Manuela data lake, and here we have two different directories: the central Kafka cluster and the factory mirror maker. So there we have two Kubernetes secrets that have embedded this certificate and key. So let me copy paste these files, and I will show you now in GitHub how it looks like. I have copy pasted the recently created certificate and key into these two files that I will show you now in GitHub. So I'm going to push the changes. Let's say update TLS secrets, and we push it. Let's go to GitHub. This is under the Manuela GitOps repo. So it's basically changing these strings, right? From the existing ones that were made to work with a previous cluster name and domain. And now, since we have changed those, we have to update the TLS certificate and the TLS key. And in the factory mirror maker certificate, we will have to change only one. So this is the same, right? The TLS CRT here and here are the same string. Okay, so I think we are ready to deploy. Let's go back to our terminal. First of all, I forgot to tell you that one of the prerequisites is also to have Docker or Podman installed in your system. I'm using Podman, and let me check the version, 2.1, 2.1. So what we have done is we have created a container image that automates some of the steps to deploy these blueprints, these repos. It basically downloads or fetches the requirements for that specific blueprint, like OpenShift install binary, OC binary, customize, and then it uses customize to render all the manifests that are present in the blueprint, create the manifest needed for OpenShift installer binary to deploy. We deploy the actual cluster and apply on top some workloads. These workloads can be some cluster add-ons like some operators like the Advanced Cluster Manager, Argo CD, Tecton, etc., or some workloads. So we have this project called K9 installer, but we have wrapped it in a container image. So in order to deploy the first cluster, which is the management hub cluster, we have to basically do this, which is Podman run. We mount up a couple of volumes. We use this K9 install image, and then we point to our repo. This repo is GitHub Monkey, the user blueprint management hub, sites, edge management hub.gcp.devcluster.com. So now it will take like 20 minutes to deploy the whole cluster and to apply the workloads. Let's wait for a little bit. Excellent. Now the deployment has finished, and we will have a cluster running on GCP with 3 masters, 3 workers, and a bunch of components and operators running on top. Don't worry if you see some errors like these ones, because this automation or this process, what it's doing is basically deploying a cluster based on an install config.yaml and applying some operators and custom resource definitions and objects that can give some errors when the operator is not running. So we are doing a loop to apply some manifests, and if you are going to apply an object that the operator or the CRD is not present in the cluster, it will give a failure. So it takes some time to to have all the operators running until that time where you are gonna apply this object, right? So don't worry about these errors. In the end, all the objects will be applied correctly. Now, if you want access to your cluster, we have this folder. This is the result of the deployment, where we can see the kubeconfig file and the password for kubeadmin user. So let's go to the console of our running cluster, of our management hub. As you can see here, this is the route for the OpenShift console. We can see the edge monkey.-hub.gcp, etc. route. And let's go to the operators section, where we will see some installed operators. So we have Advanced Cluster Manager, ACM. We have a bunch of other operators like AMQ Broker, AMQ Streams in different namespaces, Argo CD, Open Data Hub. So all these components will be needed for the demos that we are going to run on top of our edge computing network or bunch of clusters, right? We have also OpenShift pipelines, where we will see defined some pipelines. Here we go to the Manuela CI namespace. We will see the pipelines that are interesting for us. Okay, very good. Now we can check the status of ACM, Red Hat Advanced Cluster Manager. What we are going to do with ACM is basically we are going to import our edge computing clusters. In this case, we're going to import only one, and we will create some subscriptions to deploy on those clusters some components. Let's go to the pre-provision clusters that we have in ACM. So the whole demo or the whole solution right now is that we have two staging clusters, one running on GCP, one running on AWS, and one bare metal cluster that is present in the factory premises, right? So we have three edge computing clusters. However, in this demo and with these blueprints, we are going to deploy just the staging GCP cluster. This is basically a pre-provision of the clusters. So we have done a workaround to be able to self-register these edge computing clusters into ACM without the need of the user or the administrator to go to the console and perform the manual steps, right? So we have these clusters here, and we can go to Argo CD. Now we are in the Argo CD console, and we can see 4 different objects or applications that are running in our cluster. Some of them are green, some of them are yellow and red because they are degraded. There are some issues with the pods and etc. Don't worry about this because we still have to do one step. Just to explain a little bit, for example, in this Manuela TSTO, the purpose of this namespace is to basically test all the components that will be running on the factories, like the gathering of the sensors data, etc. And the problem is that the pods running in this namespace cannot pull the images back. Why? Because we haven't built the images yet, right? So we will run now what we call the seed pipelines to automatically build the images, push it to Quay, and then the pods running here will be able to pull the images. Let's go to the terminal so we can see what's running in this namespace. Manuela TSTO. As you can see here, some pods are crashing because they cannot pull the image. These are the machine sensors, blind dashboard, anomaly detection pod, the messaging application, etc. So the next step is to create or to trigger these seed pipelines, and we will do this one by one. So we'll put this in the documentation, but basically we trigger 4 pipelines sequentially. So we have to wait till one of the running pipeline is finished and successful, and then we will trigger the next one. So we go to the console, and we see that one pipeline run has been triggered, and this has several steps. So we will do a clone of the Git repo. We will make the build of the image, copy the image, push some tags, and push it to the repo once again. Then once this pipeline is completed, the corresponding pod in the Manuel TSTL namespace will be able to pull the image. So let's wait for this pipeline to finish, and we will trigger the rest pipelines and continue with the demo. While the seed pipelines are running, I wanted to mention one possible drawback, and it is that we are creating an ACM subscription to deploy Argo CD operators in all the edge computing clusters. However, we apply the channel subscription placement rule all at the same time. We have the manifest here and the blueprint management hub based 303 services Argo CD operator subs, and we apply all these 4 manifests at the same time. This might cause an issue, and the ACM team is fixing it, which makes the propagation to fail. So as we can see here, the propagation failed, and the Argo CD subscription is not correct. This has a very easy workaround, which is basically edit the subscription in the Argo CD namespace, and it's basically adding a fake annotation, right? So if we put like test fake, this will have no effect, but it will make the subscription to be updated, and the propagation will succeed, right? So now that we have fixed this, let's wait for the seed pipelines to finish, and let's continue. Awesome. So now the seed pipelines have run successfully. As we can see, these pipelines will build the images for the software sensor for the front end, customer run, and anomaly detection. These components will be demonstrated in later steps. So once we have the platform or the solution completely deployed, we will be able to perform some demos that are fulfilling the manufacturing or industrial edge computing use cases. So basically these pipelines are all the same, but they will build different components, right? So we have, as we mentioned before, all these steps. If we go to Quay, to the organization that we created before, we can see that now all these repos that were completely empty before, now they are they have images, right? So we have new images in each of these Quay repos. We have a tag, we have the pipelines have pushed images to these repos. Very good. One last step before we deploy the edge computing cluster is that the ACM registration that we mentioned before, since we don't want it to be manual and we want thousands of clusters to be self-registering to ACM by themselves, what we are doing, this is not a supported solution, but it's more like a workaround, is we are going to place an encoded, a base64 encoded version of the kubeconfig file from the hub to the KNI folder. So this will be taken by the edge computing clusters and perform the registration by themselves. So basically, we have to execute this command, base64, we encode this file, the kubeconfig file, and we place it here, kubeconfig.json. So now we have the kubeconfig file, the Docker JSON for pushing the images to Quay, the GitHub secret to be able to push commits and create PRs to our Git repos, the pull secret, and the SSH key. And we have this folder that is automatically created that contains all the manifest and basically the edge computing stack declaration that is being applied to the running cluster. Now we are going to use again the podman run command to deploy the other cluster, which is the industrial edge Let me look for the command. Here it is. Blueprint industrial edge sites staging edge GCP devcluster.openshift.com. So this process is the same as deploying the management hub. This will fetch some requirements, the OC binary, OpenShift install binary, etc. It will push, it will pull the blueprint, which is basically, as we said before, the declaration of the whole stack, and it will use OpenShift installer to deploy this stack. Once the cluster is up and running, we will apply some workloads on top, and we'll continue with the demo. Something that is worth mentioning is that once we have run these seed pipelines, and we have seen that the images have been pushed to our Quay repos, we should go back to Argo CD and check what happened there. So all the objects that were not synchronized or in a degraded state, now they are all green. And basically this is because the pods that were failing because they couldn't push the images, now they can. So now everything in the Manuela TSTL, for example, now everything is up and running. All right, so the deployment has finished, and still we see some errors here. Don't worry about this. The issue here is that once we apply the workloads on top of the new cluster of the edge computing staging edge cluster, we will see that some operators are not up and running yet, like Argo CD. And this Argo CD operator has to be deployed via an ACM subscription. It takes a little while to ACM recognize that the cluster has been imported and then deploy all the subscriptions that this cluster has. So it takes some time. For that, we have created a command which is create workloads, and it's basically the same command for create cluster, but changing this, create workloads. Then it will download the blueprint and apply workloads. Most of the workloads will be already applied to the cluster, as we did in the other deployment for the management hub. So let's wait a little bit till all the manifests are applied, and in the meantime we can go to the ACM console so we can see what happened here. If we go to clusters, now we see that one of the pre-provisioned clusters that we have, staging GCP, is imported and is in ready state. We can see that the version is 4.5.16. It's running on Google Cloud, and if we go here, we can check that the console URL is this one, user kubeadmin, and let me get what is the password for the kubeadmin user, and this is the same as we did before. Final manifest, auth, and we will see kubeconfig and kubeadmin password. Kubeadmin password is this one. Copy. Don't worry about trying to hack this because I'm going to remove the cluster afterwards. And here we are. We have our edge computing cluster. It's a 3 nodes cluster, 3 schedulable masters. This is a typical footprint for edge computing use cases in where we don't need like this minimal footprint of just one very little small device. So we have a 3 nodes cluster, and we can check the operators that are installed. So it's Argo CD. Once Argo CD is deployed and the manifest that are all applied, Argo CD will be responsible for applying new manifests. So if we check Argo CD, the route for Argo CD is, we can put it here, Argo CD, now it's not Edge Monkey Hub, it's staging Monkey, right? Login via OpenShift. Since we have the console already open, it takes the credentials. Bang, we have Argo CD and all these objects. So we have an application for the factory data center, for the line data server, the Kafka mirror maker, line dashboard. So we will see the sensors in the next steps, machine sensor, messaging, etc. Let me finish the application of the manifest and we'll keep going. Here we are, and the deployment and the application of the workloads has finished. So we go to the OpenShift console for our edge computing cluster, staging Monkey cluster, and we can see in the installed operators section that it's not only Argo CD now, we have many other operators, AMQ broker, streams in different namespaces. We have Seldon operator from ODH, from Open Data Hub, CamelK, etc. If we go to Argo CD, which is also deployed here, if we go to the console of Argo CD in this cluster, staging Monkey, we can see that now all the objects are synchronized, and basically the configuration or the deployment of our solution for AI, ML, industrial edge computing use cases is ready to go. It's ready to be demonstrated. So now anyone can go to github.com Red Hat Edge Computing Organization under the Industrial Edge docs. You can see all the Manuela checkpoints and demo modules that you can follow to demonstrate GitOps across clusters, CI/CD pipelines, machine learning, multi-cluster management, etc. So as you can see, we have all the components ready to go. We have ODH, we have Jupyter notebooks that you can import, Red Hat Advanced Cluster Manager managing edge computing clusters, and it's all good. So thank you very much, and see you in the next demo.